Okay, so now we're going to talk about the angles inside of polygons. A polygon is just a fancy word for a closed shape with straight edges, with the simplest polygon being a triangle. Yeah, so a triangle is the simplest kind of polygon. Triangles have three edges, and it turns out that if you take the angles, inside angles, we call them interior angles, of any triangle at all, they're always going to add up to the same number. And that number turns out to be 180 degrees. Okay, so the triangle I drew on the right is a little small. I'm going to make it bigger. Okay, so take any triangle, like the one I just drew. If you measure out their angles, and again, you would have to use a protractor to measure them out. We may have to practice that in class, but I'll just make up the numbers for now. So I drew one part of the triangle like a box corner, so it's a 90-degree angle. And the other two angles, I don't have a protractor on me, so I'm just gonna kind of make up values here. This may be a 30-degree angle, and the other one is larger. It would have to be a 60-degree angle. So the idea is that when you add up the three angles in any triangle, they're always going to add up to 180 degrees. So 90 plus 30 plus 60 adds up to 180 degrees. I call that an irregular example. And then there's a regular example. So there is a term, regular. A regular polygon is when the sides are equal in length. Okay, so in a triangle, I need to draw a triangle where all three sides are equal. 1, 2, 3 sides. So oftentimes when we want to communicate that we drew sides equal, we put these little hash marks on the sides. So those little marks I drew, they tell the reader that all three sides are the same size. When that happens for a regular polygon, all the angles will end up being equal as well. Okay, so let's do the math here. Triangle's got three angles inside, 1, 2, 3. Now they have to be the same number, they have to be the same amount of degrees, but they all have to add up to 180 degrees. So how much will each one be? Basically, I need three numbers that are the same that add up to 180. You can use division to figure it out. 180 divided by 3 ends up being 60 degrees each. Okay, so that's a regular triangle. Any regular triangle has all three angles being 60 degrees. And any irregular triangle will have angles may be different, but they have to add up to 180 degrees. Okay, the next polygon after triangles would be the ones with four edges. And those are called quadrilaterals. Long name, quadrilaterals, but the prefix quad stands for 4. Now, how many degrees do the four angles inside of a quadrilateral add up to? Well, you know what? You can think of the regular example too first. What's a regular quadrilateral? So what's something with four sides that are all equal? Well, that would just be a square. A square is when you have four sides and they're all equal. And again, I'll use these hash marks to represent they're equal. Now, what are the angles in a square? Well, all the angles are like box corners, so they're all 90 degrees. So I've got four 90-degree angles. What happens when you add 90 plus 90 plus 90 plus 90? It ends up being 360 degrees. So it turns out that no matter how you draw the four sides, whether they're a square or a rectangle or any other kind of shape, if it has four sides, they're all going to end up adding up to 360 degrees. So I drew a very irregular shape there. I would need a protractor to get the measures of the angles precisely, but I'm just gonna make up some number here. I'm gonna call this 70 degrees. This one here looks like it's obtuse to me, so it's more than 90. I'm gonna go with 110. I'll go with 120 degrees. This one here looks acute to me. I'm gonna call that 60 degree, no, 50 degrees. Now the last one looks obtuse to me. It's gonna be more than 90, and I've already, if you add up what I've wrote already, so I did 70, 120, and 150. If you add all those up, that's already 240. Now everything has to add up to 360. So that would mean this last angle would have to be 120 degrees as well. Okay, so I kind of just made up 4 angles without using a protractor, but I made sure that they added up to 360 degrees because that's the point. Any 4-sided polygon, a quadrilateral, they have to add up to 360. And then I'll do one more on this page. The next shape up would be pentagon. Pentagon has 5 sides. There's a famous military building in the United States called the Pentagon, and it's got 5 sides. And can you take a guess as to what the 5 angles inside of any pentagon have to add up to? Well, I won't give you too long to guess. It's going to be 540 degrees. We'll start with the regular pentagon. So I'm going to try my best to draw a pentagon with, so all 5 sides equal. Not the greatest. I'm going to give it one more shot. 1, 2, 2, no. 2, 3, 4, 5. Okay, so that's pretty decent, I think. The 5 sides are almost equal to each other. So what does each one of those, that'll create 5 angles inside, 5 interior angles. What do each one of those have to equal to? Well, you take 540 and divide it by 5, basically. 540 divided by 5. That turns out to be 108. So each of these angles is 108 degrees, and there's 5 of them. Okay, I don't have room to write all 5 out. That's a regular pentagon. All 5 sides are equal, so all 5 angles will be 108. I can try our irregular pentagon. So I need to draw 5 sides, but they're not going to be all equal. I'm going to make it easy on myself. I'm going to make a couple of box angles just so it's easier to come up with numbers. And then I'll, you know what, why don't I just make a house shape, an upside down house shape. Okay, so here I made these box corners, so these are both 90. So I've got 90 plus 90. That's 180 already. And I got these angles here. Let's just go with 135 degrees. Okay, or simpler number, I'll say 130 degrees. 130 degrees, 130 degrees. So I'll add that, those two 130s in. And now, what's this last angle have to be? So this whole thing adds up to 540. Okay, the whole thing has to add up to 540. So you have to do the math there, do some subtraction, I guess. Take 540, subtract all those 4 angles we have already. Then you get a calculator out. I'm just trying to do this in my head here. So here, let me add these 4 together. 90 plus 90 is 180. 130 plus 130 is 260. Add those together, you get 440, meaning to get to 540, the last angle has to be 100 degrees. Okay, so that's one example I just made up of a pentagon, an irregular pentagon. The 5 angles have to add up to 540. All right. And we can go on. We can go to hexagon. We could go to a 7-sided shape, which would be a heptagon. We go to 8 sides, which you might know is called an octagon, and we can just continue. And you need to know how many degrees the interior angles adds up to for all of these shapes. Now, it turns out there is a pattern. A triangle starts at 180 degrees, and every time you add a side, it turns out that the total number of degrees increases by 180. So if I wanted to know how many degrees the interior angles of a hexagon, 6 sides, adds up to, I would follow this pattern. I would take 540 and I would add another 180 degrees to it. That ends up being 720 degrees. And if I wanted to know it for the next one, which is a heptagon, 7 sides, I would follow the pattern. I'd take the 720, add another 180 degrees to it, and that turns out to be 900 degrees. Okay, so we can just kind of follow that pattern. What if I ask you for, let's say, a 20-sided shape? Then you have to follow the pattern up many, many times until you get to 20 sides. Well, it turns out there is a shortcut formula. And that is that the interior angle sum. Now I'm going to introduce a fancy math symbol to you here. So the interior angles. The symbol I'm going to put out front here, that is called sigma. Sigma. That's a Greek letter, sigma. It's a capital sigma, because Greek also has capital and lowercase. And the Greek sigma in English, well, in math, it means sum. So that's the sum of the interior angles. And it's always going to equal to, in brackets, n minus 2 times 180 degrees, where n stands for the number of edges in a polygon. So, example, I said a 20-sided shape. So a 20-sided polygon, that would be called a dodecahedron, actually. But a 20-sided polygon would have interior angles that add up to, and we would use this formula to figure it out. So you would take 20 and subtract 2, that's 18, and then you multiply that by 180 degrees. So I need to get 18 times 180. That equals 3,240 degrees. So if I take that 20-sided shape, measured all the angles with a protractor, they should all add up to 3,240. And by the way, a couple minutes ago, I actually gave the wrong name. I called this a dodecahedron. That's wrong. That's a 3D shape. Today we're just talking about 2D shapes. Okay, so I actually don't know what the name is for a 20-sided two-dimensional shape. Okay, so I'll do one example on the next page of a question, like a problem you might see. And it'll just be determine the missing angle. I'm going to draw a picture. I'm going to label a bunch of angles. One of them is going to be missing, and you have to find how many degrees it is. Okay. Okay, that's my shape. That'll be a box corner, 90 degrees. I'm gonna say this here is 110 degrees. I'm gonna say this here is 135 degrees. I'm gonna say this one is also 135 degrees. I'm gonna say this one is 100 degrees. And your job is to find out, I'll use a different color here. Your job is to find out the missing angle here, which I'll use as a question mark. Okay, so how do we figure out how many degrees it is? Well, first let's count the number of sides to figure out what type of polygon we're dealing with. So 1, 2, 3, 4, 5, 6. So we have 6 sides. That means we have a hexagon. Now that we know it's 6 sides, we can figure out how many degrees the 6 angles have to add up to. So I'm going to say the sum of the interior angles equals, it's going to be 6 minus 2, so you take the number of sides, subtract 2, and we multiply it by 180 degrees. That turns out to be 4 times 180 degrees, and that is 720 degrees. Actually, we already wrote that out on the table on the very first slide. Hexagons, the angles have to add up to 720 degrees. Okay, so then the missing angle will be whatever angle it has to be, so it all adds up to 720. So I'm going to say that the question mark equals, I'm going to take 720 degrees. I'm just going to subtract all the other angles. So we're going to subtract the 90 degrees, that's the box corner. I'm going to subtract the next angle, which is a 110. I'm going to subtract the next 2 angles. I'm going to do something fancy here. I'm going to say 2 times 135 degrees, because we have 2 of them. Might as well just, instead of writing it twice, say multiply by 2. And then we're going to subtract the last angle, 100 degrees. So if I subtract all of that, whatever is left over, that's got to be the missing angle. So I'm going to pull out a calculator here, and I'll start typing it in. Just bear with me, give me a minute here. And I get an answer of 150 degrees. Okay, so that would be the answer to the missing angle. All right, so that's the lesson on the interior angles of a polygon.